Hello viewers, I am Kausalya. Today we are going to see another derivation in time response analysis. The topic is peak overshoot. So what is meant by peak overshoot? So when you look at this diagram here, the peak overshoot is nothing but the difference between your peak value and the final settling down value, right, divided by this final value. So here for formula we are writing this one as C of Tp, that is C of Tp is nothing but during the peak time, okay, that is the maximum peak value obtained by a signal is given by C of Tp minus C of infinity. Here just for formula they are mentioning it as infinity. This is not infinity actually. That is the finally your signal will settle down at a particular value, right? So this settling value is denoted as infinity here, right? Nothing more than that. So don't get confused. So this is our formula. It is nothing but C of Tp minus 1 divided by 1. That's it. From the graph we can say like this. So here they are explain what is meant by C of Tp and C of infinity. So as I said, C of infinity is nothing but final steady state value. That is, it is the value where your signal will finally settle down, finally fall off, right? So here this is our formula. We have to find out the values of C of Tp and C of infinity and we have to substitute in this formula. So when you substitute in this formula, you will get the final expression for peak overshoot, right? So here this is your formula. This is a general expression for an underdamped case. So why we are taking mostly this formula? Because our practical day-to-day systems, 99% of the systems fall under this category, right? So here the final expression for an underdamped case for unit step input is given by this expression. This is your C of t. Now what we want? We want C of infinity and C of Tp. So first substitute t by infinity here. So when you substitute infinity, here this is your expression, that is 1 minus e power. In the place of t, I have to replace it with infinity. So when you substitute e to the power minus infinity, this entire expression reduces to 0. That is, here the 1 remains as such here, minus this entire expression becomes 0. So 1 minus 0, which is equal to 1, right? And the next thing, I am substituting t by Tp. So when you replace t by Tp, this expression gets modified as 1 minus e power minus zeta omega n Tp divided by root of 1 minus zeta square into sine of omega d. In the place of t, I am replacing it as Tp plus theta, right? So from the previous formulas, we know that the formula for peak time is given by pi by omega d. And here omega d is given by again omega n into root of 1 minus zeta square, right? So now I am going to substitute these two values in this expression. So C of Tp is equal to 1 minus e power minus zeta omega n, and in the place of Tp I can write it as pi by omega d, and again this omega d can be replaced by this expression, right? So here pi by, instead of omega d, I am writing this expression here, the whole divided by root of 1 minus zeta square into sine of omega d dot, in the place of Tp I am replacing pi by omega d. So pi by omega d plus theta. So here omega d cancel each other, and again here this omega n cancel each other, right? And the next step is we are writing the remaining terms. So 1 minus e power minus zeta pi divided by root of 1 minus zeta square, and this denominator part as such. And here sine pi plus theta. So sine pi plus theta, as we all know, it is nothing but minus sine theta. So sine pi plus theta, I am replacing it as minus sine theta. The remaining terms remains as such. So here minus into minus becomes plus. So here I had written 1 plus and these terms, right? And finally, I am going to replace this sine theta. So in order to replace this sine theta, here I am considering this triangle. So from this triangle, sine theta is nothing but opposite side by hypotenuse. And here the opposite side is root of 1 minus zeta square and hypotenuse is 1. Right. So this finally becomes root of 1 minus zeta square. Now I am replacing this sine theta with root of 1 minus zeta square. So here you see sine theta is replaced like this. So square root of this term and this term cancel each other, and finally here our expression becomes C of Tp is equal to 1 plus e power minus zeta pi by root of 1 minus zeta square. Right. And now we have find out the values of C of Tp, and we already find out what is mean C of infinity. So just substitute the values here. When you substitute the values, so in the place of C of Tp, this expression minus, here minus, and C of infinity is nothing but 1. So 1, the whole term divided by 1 into 100. So here this plus 1 and minus 1 cancel each other, and here our final expression will be e power minus zeta pi by root of 1 minus zeta square into 100. So this is our final expression for peak overshoot. Hope you people understand the video. Thank you.